Hey there, Algebra 2. It's Mr. Lamb coming to you with the second section from the final exam review. This is Unit 7, Transformations of Functions. Question 11 looks like it's broken into an A, B, C, and D. So let's take a look at parts A and B. They're actually all asking the same kind of thing. They want us to describe the transformation that is occurring to f of x. Well, the first thing that I need you to remember is don't forget that when we deal with things happening inside the parentheses, I'm going to just kind of highlight the parentheses here in red. All right, when I have parentheses, that's what's affecting my x variable. All right, that's what's affecting side to side. So my transformations, my translations will go left and right. My stretching will be horizontally. The flip will be across the y-axis. So anything that's happening inside the parentheses is dealing with the x variable. Anything on the outside is dealing with the y variable. The thing that you have to remember is anything that happens inside the parentheses is backwards. It is a lie. It is the opposite of what you would expect it to be. So as I look in A, I see this minus 3, where I am subtracting 3. And remember, this has to be opposite. So instead of moving to the left, which is what your brain should be trying to tell you, this means you are going to translate it right 3 units. We're going to translate it right 3 units. The other thing that's happening is I have this 1/2, and it is outside of the parentheses. So I don't have to think about it being backwards. This is outside. So it is half as big. If you think about taking something and making it half of its size, that means you are compressing it. And that is a compression. It is outside, so that is my vertical. So compression vertically by 1/2. We are going to make all of the y's half as large. Those are the 2 transformations in part A. In part B, let's take a look inside the parentheses. All right, I see that 2 times. All right, again, it's in parentheses, so I'm thinking opposite. So instead of thinking, oh, it's twice as big, it got bigger, it got stretched out. Remember, we have to think opposite, so we're going to think compression. And side to side, we'll call that horizontally. By a factor of 2. And then on the outside, I have this minus 7. It's outside, so it's going to tell me exactly what I need to know about the y. So this is an up and down, and since it's minus 7, this thing goes down 7. So a compression horizontally by 2, and it went down 7. For C, we look inside the parentheses. Inside the parentheses, I see plus 1. That's the opposite. It's in parentheses, so left 1. The 4 is outside. That is a stretch. It's outside, it's y, so vertically by 4. In the negative sign is a reflection across. And if you think outside, you're changing your y, so you're making your reflection is doing something like this. You're flipping from a top down, so that would have to go across the x-axis. Because the x-axis would be the one running side to side that you would be flipping over. For D, if I look inside parentheses, I just have the negative. So that's a reflection. Over. And if I think about my flip for my x's, my flip is going this way. It's going left and right, which means it would have to go over the y-axis. And on the outside, I have a +1, which means it went up 1 unit. All right, number 12 says complete the following definitions of even and odd functions. These you can just kind of look up if you need to. But a function is called odd when the opposite input values give opposite output values. So if the opposite x's give opposite y's, then it is odd. You can kind of think of that O, the letter O in there. Opposite, opposite, odd. These functions have graphs that are symmetric about the origin. That means it is 180 degrees rotationally symmetric around the origin. A function is even if when opposite input values give the same output values. These functions have graphs that are symmetric over the y-axis. Number 13, they have two graphs here. They want to know whether the graphs are even or odd. And if I look, I'll look at symmetries. There's y-axis symmetry. That graph is cut in half by the y-axis. This is even. As I look at B, I drew the y-axis in. It is not symmetric to the y-axis, so I know it's not even. So I need to try a 300 or a 180 degree rotation to see what it looks like. So let's take this one and rotate it 180 degrees. And if you look at the two graphs, they are still the same shape. This is odd. It is an odd function. That is it for Unit 7. See you soon.